Hi guys, this is a fourth video in the series on networks. This video is on planar graphs and Euler's Law. So there's sort of two key things you need to know in this vid. The first thing would be, excuse me, let me get my pen. First thing would be, come on. First thing would be the planar graphs, what that means, what the difference between a planar and a non-planar graph, and the second thing would be Euler's Law, what that is and what does it mean. Okay, these are the key definitions. There's just three from today. You're going to know what those words mean and how to apply them, and then these questions from exercise 9D from the Cambridge text. All the examples are from Cambridge. General mathematics. So first thing, what's a planar graph? Okay, so basically a planar graph has no intersecting edges. If I was to draw this graph here, like that, if I get my vertices right, so big dots as vertices, and I've got my edges, that's A, B, C, D, that's a non-planar graph. Okay. It's non-planar because these two edges are intersecting, and that's the definition. Basically, if you've got intersecting lines, intersecting edges, it's non-planar. So this graph here, graph 1, is non-planar, and I can turn it into graph 2 by removing the intersecting edges. Okay, so in this case what they've done is they've taken that vertex and they've moved it to the middle here, leaving that edge as a curved edge on the side. So that's one way to do it. Another way to do it is, and I think the more effective way, is you identify what vertices are intersecting. So in this case I've got A to D and C to E. Okay, so in this example what I'll do is I'll say, okay, let me just get my eraser. That's when I'll erase those bits there. In this case I'll say, okay, A to D is my intersecting edge. I want to change that so it's now a planar graph. Okay, so I'm going to take that and I'm going to redraw the graph with that edge removed. So A, B, C, D, F and E. Like that. A, B, C, D, E and F. And what I've done is I've removed the A to D edge because it was causing my graph to be non-planar. Okay, so what I'll do is I'll just reconnect it like that, and all of a sudden that graph is a planar graph. And you can sort of see it sort of seems a bit, like I'm just deliberately removing it and reconnecting it. That's all you need to do. That's what a planar graph is. It doesn't matter how you reconnect it. It can be on the other side. There's many answers to these sorts of questions, but you can't have intersecting edges. Okay, and that makes that graph now planar. Okay, so why planar and non-planar is important is because graphs have a third property. So we've learnt about edges and vertexes and the degree of vertices. A further property is what's called a face. Okay, so a face is a closed region of space within and around the graph, or around the graph. So this graph here has two faces because we've got the inside area and then the outside area. This graph has four faces because it's got three windows made by the connections between the edges and the vertices, and then the fourth face on the outside. Okay, and why faces are important is because Euler discovered a relationship between the faces, edges and vertices within all planar graphs. I should say planar and connected. planar and connected graphs. And he said, he showed that the number of vertices minus the number of edges plus the number of faces will always equal 2 for a planar connected graph, or symbolically this equation here. Okay, so I'd have that written down somewhere. That's an important equation. So this example is about verifying the formula, just showing that it works. And it says, consider the connected planar graph shown below. Write down the number of vertices, the number of edges, and the number of faces. So vertices, edges, and faces. Okay, so this has 4 faces, F1, F2, F3. Okay. I'm just in the middle of a video, Zach, so just can you hold on for 30 more seconds? Yeah? All good? And face 4, it has four faces, 4 vertices, and then for the edges you want to count the edges and cross them off. This is 1, 2, 3, 4, 5, 6 edges. Okay, so it says here verify the formula. All you need to do is write the formula down like that and then substitute. So the edges is 4, the vertices is 4, sorry, the edges is 6, the faces is 4, and does the left hand side equal the right hand side? So 4 minus 6 is minus 2, plus 4 is equal to 2, negative 2 plus 4 is 2. So the left hand side equals the right hand side. You've got a verified formula. Cool.